thank you everyone about your time to attend this FMRI webinar regarding the promises and perils of travel activity behavior analysis. It's our pleasure to have Dr. Pourabdollahi, I'm sorry, I try my best, with us today to talk to us about the perspective, of from the industry point of view. So Dr. Pourabdollahi serves as a new transportation planner with RS&H transportation infrastructure practice, where she leads and supports travel demand modeling, planning, and data mining efforts. She has experience in travel demand modeling, freight transportation logistics, of course, supply chains that everybody's talking these days, discrete choice analysis, survey design and conduction, data mining, statistical analysis, emissions study, and operation research. She received her Doctor of Philosophy degree in Civil Engineering from the University of Illinois at Chicago, with her research focus on supply chains and freight transportation modeling. She serves on several transportation research board (TRB) standing committees, including travel behavior and values and freight planning and logistics. And I think I have met Doctor over there. This. So, Dr. Pourabdollahi, please, the floor is yours.
Thank you so much. Thank you, Dr. Kaiser, for the introduction. And good afternoon, everyone. Thank you for having me today to discuss some of the things that we do at work in the industry, view about on data and specifically travel activity data and travel activity behavior analysis. So, this going. So today's presentation, I'm going to talk about the travel activity data and showcase two applications of data for analyzing passenger and freight mobility. The agenda is a brief introduction to travel activity data, the types of data, collection methods, and the first application is a study that analyzes the e-shopping trends using national household travel survey data. And the second one is evaluation of commercial truck trip patterns in a Florida region using GPS data. And finally, we can discuss the findings, and if there's any question, I'll be happy to answer. So, travel activity data include different and diverse type of data. The most prominent type are the conventional travel survey data and traffic data. And then there are the new and emerging type of data that are collected usually passively, like GPS data, Bluetooth data, and mobile device data. And now we have social media data that are being used for travel behavior analysis, like Twitter data. The data also can be classified as publicly available data from public domains and the proprietary data that usually come with a cost. And what are these data are used for? These data can be used for several purposes, like from identifying the travel patterns to mobility analysis, developing travel demands for both passenger and freight, and understanding and evaluating the impacts of the travel on geographical distribution and built environment. They can also support decision makers and officials from regional, state, and even national agencies for transportation related planning and policy makings. One of the main purpose of the data, the travel activity data, is to help modelers such as me to develop and apply activity and agent-based travel demand model, which in turn are used for mobility analysis of human and freight to understand and forecast how individual and goods perform activities and move in time and space. And with that, we go through the first application. We're going to look at, in this application, we're going to look at an online shopping, also referred as e-shopping or sometimes e-commerce in the United States, and explore the factors that affect the frequency of online shopping. Since the late 90s, e-commerce has taken off in the US and everywhere in the world, and there has been every year there has been a steady shift from traditional physical shopping, like going from home to the store to shop, to the online shopping, ordering for delivery to your place, to your house or work or wherever. And based on, according to the United States Department of Commerce, last year during the COVID-19 pandemic, there was a huge spike in the growth of e-commerce. The average annual 15% growth increased by 30% and was close to 45% annual growth for 2020. So with all these changes in the shopping behavior, there comes changes in the shopping trips. The characteristics of the shopping trips are changing, and there is also an increase in delivery truck delivery truck trips in the region, especially to the residential areas. Especially, it was obvious where we live in the last year, the number of UPS, Amazon trucks that are passing on a road delivering packages to residential houses. And therefore, all these changes brings up the changes into associated externalities with all these trips, like congestion problems, safety issues, or emission problems, which are more critical in residential areas. And this brings up this big question, important question: what will be the net effect or net impact of these changes on the regional travel patterns, or for the planners? So understanding the effect, the net effect on the region, the net effect of the online shopping, increase in online shopping on the region, requires looking at the frequency of these shoppings and driving factors. What are the influential factors that encourage people to shop online? We want to know specifically who are these e-shoppers or online shoppers and how frequently they shop online. So that was the main purpose of this study. For that, we used the 2017 NHTS. The National Household Travel Survey is conducted by Federal Highway Administration. It is the authoritative source of travel behavior of American public, and is the only national data that provides capability to analyze the trends at personal and household levels. It includes non-commercial travel by all modes, including characteristics of the people, the household characteristics, even the data on the vehicles owned by the respondents, and it can be used for to provide a variety of statistics on different measures, and can be analyzed for that. So the 2009 NHTS, which was the previous version of the survey before the most recent one conducted in 2017, a new question was added to the questionnaire, and it asked this respondent about the frequency of their online purchases. The question was number of times that you have purchased online for delivery in the last 30 days. In 2017, in addition to that question regarding the online shopping frequency, a couple of other questions were added regarding the internet access and adoption of technology, like if you use PC or laptop, any smart devices like tablet or smartphones. Those were new questions in the 2017 versions that can be very helpful in analyzing some behaviors regarding the internet use and eventually online shopping. So the NHTS finds that households' physical shopping frequency has declined, the physical shopping trips, while other data sources show that the delivery by parcel delivery trucks has increased over the past decade. This is the comparison of the 2009 and 2017, just the trends. As you can see, the 2017 data in red shows that almost 60% of American population reported that they purchased online at least once in the past month, compared to only 47% in 2009. So the data provide a very good sample for the analysis. More than 235,000 of usable records with a valid answer to that question regarding the frequency of online shopping. All these records were reviewed and processed for the model estimation. The graphic on the left shows the distribution of online shopping frequency for the sample. And the final data set included, for the analysis, included more than 70 variables that could be used as explanatory variables in the model or covariates in the model to analyze the behavior, the online shopping behavior. These were classified into 5 different categories: the socio-demographic and socioeconomic characteristics, the health and physical activity related attributes, the built environment and land use attributes, transportation and travel related characteristics, and also internet and technology adoption attributes. For the analysis of the data and the trend analysis, we used the decision tree approach. Decision trees are versatile machine learning algorithms that are usually used to classify big and complex data and reveal the interdependencies. They are mainly developed based on 2 methods, either regression or classification. They are very efficient data mining techniques for feeding big data and complex data and identifying interdependencies. If you are familiar with them, you know how easy they can be developed and how intuitive they are. But if you're not, I have included a very simplified format of this decision tree here to show how they look like, how they work. They actually look like an inverted tree, and they include nodes and branches. Nodes are basically the covariates or explanatory variables, and branches are every time that the data splits based on the covariate, it becomes classified into new subsets that form the branches. And then there are the final leaves. When the tree is built, final leaves, or they're called buckets, that show the final decision based on the covariates or explanatory variables. We use the statistical computational software R to develop this tree. The data, the NHTS data, was divided into train and test subset. The tree is developed based on the train data, and then the test subset is used to evaluate the accuracy of the model, calculate the accuracy, the errors, basically. So different algorithms can be used to build a model, build a decision tree. The most common is the classification and regression algorithm, or CART, and the splitting method of entropy or information gain. If I want to simplify how this algorithm works, is that it's it the make it's be, the method works like recursively splitting the data at every node to build further subsets of data until a termination criteria is met. And the termination criteria is based on independent variable that results in the minimum heterogeneity of the dependent variable. So, for example, this example of the tree is built to result in the minimum heterogeneity in the final subset of the data. Oh, there is a common issue with the decision trees, and that is overfeeding. Like if you develop a full-grown tree, it usually overfits the data, which hurts the predictive accuracy of the model. So, and there usually some parameters or criteria are used to control the growth and find the optimal tree that is fitted well to the data, but also has a good predictive capability on the test data. For this analysis, we use the complexity parameter to control the growth of the tree and find the optimal tree. So if I want to summarize the process, the idea is to allow the decision tree to grow fully and observe the critical parameter and calculate the cross-validation error and find the optimal critical parameter value, and based on that, prune the tree. Like it's called actually a pruning. Prune the tree to make it smaller and more accurate. And this is the result of the final tree that was developed based on the NHTS data. It has a depth of the final tree has a depth of 6, 43 nodes, and the data has been split 21 times. And this is the rotated tree, the final tree. I don't know how well you can see it, but I'm going to explain the results, what's the finding in this tree based on this data. So the dependent variable, as I said before, was the frequency of monthly online shopping. It was classified into 6 groups. 0 times the 0 frequency, 1 to 2, 3 to 4, 5 to 6, 7 to 10, and 10 plus. And this last leaves, basically, or buckets, are showing the propensity of each of these groups, propensity for shopping with each of these frequencies. So based on the result, 4 types of those covariates within those 4 types of variables were found out to be significant in explaining the frequency of online shopping. Included the socio-demographic characteristics of the individual. This included the age, employment, education, socioeconomic characteristic of the household, like income, technology adoption, and internet usage, and some of the travel-related attributes within the data, specifically the driving status and using ride-sharing mode for travel. So the results showed that the least likely online shoppers are basically individuals with lower education, like high school diploma or lower, who never use laptop or PC to access internet. Those are the least probable online shoppers. This was followed by Americans of age 55 years and older with higher education than high school, but very low internet usage, like a few times a month. Also among the least online shoppers are individuals with high school diploma or lower education level that have access to laptop and PC and use internet, but they do not work and they do not drive. I mean, this sounds like very young respondents in the survey to me, like teenagers probably. And then there are the last group of the lowest least likely online shoppers are 35 years and older workers with low education, like lower than high school diploma, who has access to internet, but they do not have a car. They do not have access to car. And then on the other hand are the most frequent online shoppers. Who shops the most in America? The individuals with higher education, like college and university and higher, and who has daily access to internet and use internet on a daily basis, and belong to the household with higher incomes. And within this big group of the people, those that have preferences of using ride-hailing application and ride-hailing services such as Uber, Lyft, and like taxi services even have higher probability of shopping online. And there was another interesting observation within the result of the decision tree model. Among these people, the people with flexible work schedule and option to work from home are more probable to shop online. So based on the available data, online shopping is well embraced by American population. However, as the results showed, there are some variations in adoption of the online shopping based on age, income, education, adoption of technology, and travel preferences. So if I want to like summarize the attributes that have been found significant in explaining the frequency of e-shopping, their age, household size, employment, education, income, and work from home option or flexible work schedule, and frequency of internet use, ride-sharing application usage, and frequency of using those ride-hailing services, and also driving status. But interestingly, some of the covariates that I thought would be found significant, they were not found significant in explaining the frequency of online shopping, including sex, built environment attributes, health and disability related attributes, and some other transportation related attributes such as access to public transport or number of cars owned. So the findings of this research can be used in activity-based modeling, especially modeling of in-home activities and modification of the shopping activity or shopping trips. They can also be used in planning for last mile delivery and urban freight planning, but further discussion and analysis on these are definitely required. With that, we enter the second presentation, the second application, basically. This second application is on revealing commercial truck trip patterns using a GPS-based data. Traditionally, truck trips are considered single trip between distribution center and a destination, shown here, but the data and observation has shown that this is not the case. Usually truck make multiple trips and the truck trip patterns or have more of a tour-based patterns or a chain of trips instead of single trips. So an example would be like a UPS truck delivering packages. It doesn't make only one trip from the fulfillment center to final destination. It probably makes tens of trips on a daily basis and stopping at several locations delivering packages. Trip-based models disregard this interdependent temporal and spatial interdependencies between the stops, but tour-based structure, which is a more advanced structure for modeling truck trips, considers these interdependencies and are considered a superior form of truck modeling, basically. But to model a tour-based truck, basically develop a tool-based truck model, we need to have longitudinal data that provides information on truck movements. And GPS-based data do that. GPS data provides spatial and temporal information on truck movements. However, they require extensive processing usually. And they are usually proprietary type of data, comes with a cost and sometimes confidentiality and non-disclosure agreement that can be restricting in research. And for trucks specifically, they have limited information on other attributes, such as like the type of cargo being carried or other logistics information, the type of activity being performed at each stop. But for today, we are going to show how we used a GPS data to reveal regional truck trip patterns for modeling purposes. This was a project that was delivered to Florida Department of Transportation in District 7, Tampa Bay area, as you see here. And for this purpose, we used the GPS data from ATRI, American Transportation Research Institute. The ATRI data was obtained for 7 counties in the region and a 10-mile buffer around the region for 8 weeks from October 2016 to July 2017, 2 weeks in different months during that period. It gave us more than 96 millions of records and information about like 110,000 trucks. And but what actually the data gives us is very basic. It's like every GPS record data, or they call it GPS pings, have 6 attributes only. A truck ID that is unique. Each truck has its unique unique ID. A longitude and latitude for every ping, and a timestamps for every ping. A date, a time and date. And there's some information on the travel speed, but it was not for all records. Some missed those information. And there was some heading information for the truck, north, south, east, west, which direction the truck is heading. But not for all the records. The last 2 attributes were partial information. And on the right side, you can see a partial distribution of the pings in the region. So the data required a lot of processing and cleaning to provide us the information that were required for analyzing the truck trip patterns. This graphic shows the process basically. It started with general QA, QC, and some cleaning, then identifying the moving and stop records, and then stop filtration and tracing movements. And then we move to geospatial analysis to infer the destination and location in the route options. And then we were able to get the tours and trip tables by purpose. So as the graphic showed, there's extensive pre-processing from going from GPS pings to GPS traces to getting the route, destination, and activities for this truck. A Java application was developed to process the data, and this is a summary of the steps that were taken in that application. Like basically, it sorted the data by the truck ID and time to have the records, consecutive records correctly, and then using the timestamp and latitude and longitude of each record, the distance, duration, and speed between the 2 records were calculated. And then these information, the distance, speed, duration, were used to identify the first record for each truck ID, the records that show a movement or a moving record, and the records that show a stopping or stopped record, and the last record for each truck. And then those records that were identified as stopping or stopped pings were clusters to one stop, like because when the truck stops, they like can transmit several pings to or show several records. And then these were used to trace basically the movements of the trucks and show the stops. And then they were integrated with the land use, employment, and network data to show the route, location of destination, and then infer some activities. This next few slides are the examples of how the data was processed. We identified two specific type of tours in the region. We call them regional tours that started and ended within the region boundaries, and all the intermediate stops were inside the region, and external tours that start or stopped or ended outside of the region. Like they had a stop or a start or end point at outside of the region. This is a random truck ID. And with this truck, there were 596 GPS records associated. And after processing, we identified 6 tours. And these are all the records. They are all within the same area and probably same routes. And in the background, there is the TAZ layer of the Tampa Bay model, the District 7 regional model. And we selected tour number 1, which were associated with 73 GPS events of that truck, and identified the stops of this tour, which were 4. And these are the stop points of this tour. And we did the same thing for all, and this is just showing you an external tours. The external tours started outside the region. For example, this truck ID had like 5 tours, 553 GPS pings, and most of them more or less started from within the same area, but with very different patterns. Like some were like regional true movements. They didn't even stop within the region, but some showed the stop. We picked the tour number 1. These are all the GPS pings associated with the tour number 1, and 5 stops were identified after processing of this tour, and these are the stops shown on the TAZ level. And then the next step was to integrate these information, the process data with the network information to reveal the route choice and also location of the stops, destinations. We're also able to use the GPS data to analyze some other patterns of the truck trips, for example, temporal variations. These are the truck activities for days. Like as you can see, like the weekends show much less activities than the weekdays, and for the different months that the data were collected in. We also looked at the temporal variation of the truck activities within a day, and as expected, the peak truck activity is around noon, with the peak period from 10 a.m. to 1 p.m. and peak hour between 11 to 12. We could also look at, using the data, look at the frequency of the stops in the tours and the stop purposes. And we saw 2 different trends for the external tours and regional tours. External tours had fewer stops, while regional tours showed more stops, 2 and 3, with an average of 3. And the stop purpose was inferred using the land use and employment employment data that were fused and integrated with the GPS data. And we also looked at the destination at a higher resolution to higher resolution than TAZ to see what are these facilities that trucks are stopping at. And these are just the top 10 destinations within the region. Of course, Port Tampa was ranked the #1 and #2, different parts of port. And there are distribution centers, warehouses, intermodal yards, and also truck rest areas and mobile modular facilities that uses containers, empty containers to build other things. So that was basically end of the applications. And as a summary of findings, I think you can see that travel activity data improve our lives, enable the understanding of travel patterns. They play a critical role in travel demand monitoring, transportation planning, and policy decision support. There are three types of data, I believe we can categorize, like conventional travel behavior data, such as NHTS. These have been and are still our primary source of travel behavior information, but they are highly costly. That's why they're less frequent. You don't see every year survey, hassle travel survey. They're usually conducted within the 5 to 10 year span. And that makes them cross-sectional. They do not provide any longitudinal information on travel behavior. And they can involve errors associated with travel survey conduction, but they provide very detailed information on behaviors, and they are usually self-validating. On the other hand, there is the passively collected data. They're very effective, but they cannot be used independently for travel behavior and inferences. They can be used as a supplementary data input to analyze the travel trends or behaviors. They come with a more reasonable cost. They provide longitudinal information, but require processing, fusion, analysis, data imputation, inferring, and integration with other existing data, as was shown in the second application. And sometimes they have validation issues. And then there are the emerging data, which are social media and big data like Twitter. They unbelievable how they can provide such data on travel behavior and activity trends. So as was shown, the fusion and integration of different data types seems inevitable. Some have advantages that the other lacks. So it seems that to have a most comprehensive travel activity data, it would be beneficial to integrate and fuse different types of data to get more out of the data. And big data is a future. So advanced analytical methods and data mining methods require skill to overcome the challenges that are associated with big data analysis. And the last decade has shown that travel demand research field or transportation research field is becoming a more integrated field, science field with the data science and computer science field. And there are some overlaps, like you can work in either industry, I believe, if you have some specific skills. And with that, I finish my presentation. Any question I would be happy to take.
Thank you so much, Dr. Pourabdollahi. At this time, I will be taking questions. And also feel free to speak up if you have any other questions.
Any question? Do you have any question? Valentina, can you hear me?
Yes, I can
Yes,
hear
I
you.
can.
Okay. Do we have any question for the doctor?
We do not at this time.
Okay. Also, if they haven't said any question, maybe they can ask directly, mute themselves and ask directly.
Yes, yes, absolutely. I can share again the contact information. They can even actually share the presentation and with them and contact me if any questions come up with them.
It was very interesting presentation. It was very interesting presentation, and please allow me to ask you one question. What do you think, very general? What do you think that we are going with the freight these days? Okay, especially with the bottlenecks that we have in the major intermodal facilities like a port. Okay, and how engineers like you or others that work in travel demand forecasting, travel demand modeling, they can help. Okay, the supply chain.
Yes, yes, interesting. Like with all the last year showed like so many flaws within the supply chain. We are still like suffering from the supply chain disruption due to COVID. Like the cost of construction materials is tripled, I guess now, and it's all an effect of the disruption within the supply chain. I think now the most important thing in freight transportation, freight mobility is resiliency, especially the supply chain resiliency, to foresee or be prepared for events such as like a pandemic, how to respond to that. So like it was crazy. We ran out of the toilet paper. I mean, and so I guess the most important thing, especially with the last year pandemic and the effects of it on the supply chain, would be the resiliency question. How we can model to forecast such disruption in supply chain, how we can be prepared for this. And it comes like it can come in different like planning or policy measures, like changes in like even inventory like planning, like it can be different. So to deal with this disruption, I think that's the most important. And another one is the online shopping. Online shopping is something that is not going to is going to grow more. Although they say that it was a pandemic response that increased, that spike in the growth of online shopping, but I don't think that it's gonna go back. If anything, it's gonna grow more, and with that comes another issue of the urban planning and how modeling of these delivery truck trip patterns is a big challenge. It's gonna be a big challenge because we don't even have like most of the regional models and statewide models. They are not even like tour-based model. They are like trip-based model, very, very straightforward models. They do not capture the movements of these medium-sized trucks into the residential areas. So that's another issue that modelers can help. It's going to be an interesting challenge. But now I believe we have the data. The data is no more a problem. It's just basically the modeling and implementation of these into the regional and statewide models.
Excellent. Thank you. Thank you. Excellent. We are receiving a lot of calls from different entities regarding, the supply chains and resilience. And it looks like that state and federal, they are really worried about all these bottlenecks and logistics in general. Hopefully things will be better, but I don't think will be better soon. I think we have also labor shortage that makes the difference. We will see. Any other question? Any question from Valentina or Vasquia? the WTS and IT FAQ chapter. Actually, my apologies. I wanted to mention that this event has been sponsored by the FMRI and the WTS FAQ chapter. That Valentina is doing a great job supporting activities from WTS point of view.
Dr. Pourabdollahi, I do have one question. So how long did it take you to get all of this data? How long have you been working on this?
Okay, so the first application, the online shopping trend, is the data is publicly available. It's the national data source, so it's not difficult to download, to get the data download. You just have to download the data. And the analysis, like if you're familiar with R, it would be straightforward and easy. Like maybe like the analysis would take, it took me over the summer. So I started, like I was thinking about it, especially with this rise in online shopping. I was interested to see if the previous data show anything that can be used for future. So it took me like maybe a couple of months working on the side. It was like a self project. But the second was as an actual project, an RS&H project, and it took about a year to acquire the data, process the data, and develop the model, because that GPS truck data was eventually used, and a tour-based model was developed for the Tampa Bay region within the regional model. So that took longer because it wasn't only the data processing and statistical analysis of the data. It was actually the model development and implementation into the regional model.
Got it. Thank you.
Sure.